Hello, Assalamu alaikum. Today I am going to discuss about IGCSE O-level physics, O-level physics, Unit 8, Chapter 26, Motion in the Universe. In the universe. We live on a planet called Earth. It is one of many planets that together with their moons form our solar system. So আমরা যে প্ল্যানেটে বাস করি তার নাম হচ্ছে আর্থ. It is one of many planets that together with their moons form our solar system. Remember, gravitational forces hold our solar system together. These forces cause the planets, asteroids and comets to orbit the sun, and moons and artificial satellites to orbit the planets. In this chapter, we will look at the key role played by the gravitational forces in controlling this movement. After finishing this chapter, we can explain that gravitational force causes moons to orbit planets, causes the planets and comets to orbit the sun, causes artificial satellite to orbit the earth. Understand why gravitational field strength G varies and know that it is different on other planets and the moon from that on the earth. We can also describe, after finishing this chapter, the differences in orbit of comets, moons and planets. We can use the relationship between orbital speed, orbital radius and time period. First, in this chapter we have to learn about what is gravitational force. Gravitational force. In our universe, every object attracts every other object due to their masses. The mutual attraction force between any two objects due to their masses is called gravitational force. The mutual attraction force between any two objects due to their masses, masses is called gravitational force. So in our universe, every object attracts every other object due to their masses. So mass of the first object is, say, m1 and mass of the second object m2. These two objects attracts each other due to their mass. This force is known as gravitational attraction force. So there is a gravitational attraction force. Remember, gravitational force always attractive, and gravitational force is due to the masses, due to their masses of the object. When any object revolve around an axis or another object, then there are required two forces. One is centripetal force, whose direction is towards the center, and another is centrifugal force whose direction is outward from the center. So now we discuss about why do objects move in a circle. Why do objects move in a circle? Say this one is the sun, our sun. Eight planets revolve around the sun in a circular orbit. Say this one is the a planet, and it is a star. Say our sun. So a planet revolve around the sun or a star in a circular orbit. There are required two forces. One is centripetal force. Centripetal force. So direction of the centripetal force is towards the center of the star or sun. Here a gravitational attraction force supports this centripetal force. On the other hand, due to circular rotation of the planet experiences an outward directional force, whose name is centrifugal force. Centrifugal force. Remember, the direction of the centrifugal force is outward from the center of the sun. When these two forces are in balance, then a planet revolves around the star or the sun in a circular orbit. So planets and comets travel around the sun. Moons and satellites travel around the planets due to gravitational attraction force. Newton's suggested that between any two objects there is always a force of attraction. This attraction is due to the masses of the object. He called this force gravitational attraction force. He suggested that size of the force depends on the masses of the two objects and distance between the center of the two objects. Say here it is one object M1 and another object M2, and distance between two objects is D. So the amount of attraction force according to the Newton's laws of gravitation, gravitational attraction force is directly proportional to the product of two masses, and also inversely proportional to the square of the distance between them. That means if the product of their masses becomes double, then force will be doubled. If the product of their masses becomes 3 times, then force, gravitational attraction force, will be 3 times, tripled. On the other hand, if the distance between two objects becomes double, then forces will be 1/4. Why 1/4? Because we know force is inversely proportional to distance. If the distance becomes double, then 2d square, so it will be 1/4 of 1 by d square. So the 1/4 of the previous value, remember. So the greater the masses of the two objects, the stronger the attractive forces between them. If the distance between the masses is increased, the force between them decrease. So combinedly we can write F is directly proportional to m1 into m2 by d square. The proportional sign can be replaced by equal sign by multiplying a constant. Here g is the gravitational constant, universal gravitational constant. So this is the Newton's law of gravitation. Newton's law of gravitation. Our sun is massive. It contains over 99% of the mass of the solar system. It is the gravitational attraction between this mass and each of the planets that hold the solar system together and causes the planets follow their curved paths. Those planets that are closest to the sun feel the greatest attraction and so follow the most curved paths. Planets that are farthest from the sun feel the weakest pull and follow the least curved path. So if it is the sun, uh, and first one is the say Mercury, and second one is Venus. So second one is Venus, second planet Venus. Is the orbital speed of the Mercury is same for Venus? No, because the gravitational attraction force between Sun and Mercury and Sun and Venus is different. That's why the orbital speed also different, because the orbital speed depends on the gravitational attraction force between Sun and the planet, and also depends on the distance between Sun and the planet. Here the orbit for the Mercury is closer than the orbit for the Venus. So Mercury planet Mercury experiences more force than that of Venus. That's why Mercury feel the greater attraction, so follow the most curved path and its orbital speed is more.